Hello, welcome to another series of our statistics explanation. Today we are going to discuss the paired t-test, also referred to as the t-test related. We are going to focus on understanding the paired t-test and the steps involved in calculating the paired t-test. Okay, let's begin. Now, the paired t-test is used when the same participants are involved or are being tested under two conditions. That is, the same participant A, does condition one at time one and time A or at time X, and the same participant A does condition two at time Y. What we are simply saying here is that the participants that are involved in one aspect of the experiment will be involved in the other aspect of the experiment. Let's take the uh, control and experimental group. In this case, the participant is in both the control and in both the experimental group. T-test is appropriate for comparing two related samples, such as measurements taken before and after an intervention. It's a very good tool when you are trying to test uh, data from experiments that you took before and after the experiment. For instance, if you checked, let's say, something like blood pressure of a group of individuals before the administration of a particular therapy, then and after the administration of the therapy, you also took their blood pressure scores are now measurements before and after an intervention. The t-test is also known as the related sample t-test, like I told you before, and it assesses whether the mean difference between pair scores is significantly different from zero. When do we use the paired sample t-test? When do we use it? The paired sample t-test should be used when the same participants are exposed to both conditions. This is very crucial in understanding the use of it. And then the data is interval or ratio. That means the data we are obtaining is in the interval or ratio form. Never use the t-test, the paired sample t-test, or any t-test whatsoever, when the data is in nominal, that is categorical data, or when the data is in ordinal form. And thirdly, you use the paired sample t-test when you want to compare the means of two related groups. When you want to compare the means of two related groups. Okay, let's look at an example of the use of the paired sample t-test. Go back to an experimenter predicted that participants would recall more words from a simple text than from a complex text. Then this experimenter probably went to the field, got sample data, and in the sample data, all participants were given 2 minutes to read a simple text, and then another 2 minutes After creating the simple test, they completed a test. Yeah, they completed the test, and after 10 minutes, they were after 2 minutes of reading the test, they were given 10 minutes to record the words and complete a test. Uh, then they also did the same thing the other way around. They were given 2 minutes to read the complex test, and after same 10 minutes, they were given time to record the words. So this is a typical example of data that we can use for um, the paired sample t-test. But it's important that you know that we have the problem of other effects. So we have to counterbalance. So assuming you have a group of participants, maybe 10 involved in this experiment, all of them cannot be involved in the simple text at once and then the complex test. You may have to split them. Half of the participants will do the simple text at time A, while the other half will do the complex text at time A. Then at time B, you go the other way around. Those who do the simple text at time A will now do the complex text at time B, while those who do the complex text at time B will do the simple text at time B. So we have an assumed set of data for such as experiment in table 2, and that's it. That's the table. And in this table, we have the recall scores for simple and complex tests. And we have a set of participants. We have 10 sets of participants. 10 of them participated in the experiment for the researcher to be able to uh, test the research hypothesis that predicted that participants would recall more words from a simple text than from a complex text. Then we place them in the table, see how they are placed. We have condition 1, the simple text, and then condition 2, the complex text. These are their recall, what they could recall in the after giving them the simple and complex text. And you can see their mean scores. Now our goal is to check whether the mean scores for simple text 6.4 and the mean score for complex text 3.7 is significantly different. Note that to get the mean score, you add all the scores in the simple text. I think from what we have here, you will get 64. And then when you divide it by the number of participants, you will get 6.4. That's a simple way to obtain the mean. Then the same thing is done for the complex test. You add 2174452 534, and you get 37. And when you divide it by 10, you will get 3.7. Now, for us to do the t-test, per sample t-test, we have to calculate just like we did in the Pearson correlation. We have to calculate the difference. If you have not watched that video, you can take a look at it. You have to calculate the difference and then square the difference. So to get the difference, you subtract condition 2 from condition 1. That is 10 minus 2, 8, 5 minus 1, 4, 6 minus 7, minus 1, 3 minus 4, minus 1, 9 minus 4, 5, and so on and so forth. You get this data, and then you now add up this to get the summation of D. This is the score we obtain, 27, by adding 8 plus 4 plus minus 1 plus minus 1 and up to this, you get 27. Then the next column on the table is to square the difference. 8 square will give you 64, 4 square 16, minus 1 square will give us 1, minus 1 square will also give us 1, 5 square will give 25, and so on and so forth. And then when you sum the difference, the square of the difference, you get 151. So this is what you should note. The difference D is calculated. The difference is D are calculated by subtracting the scores in condition 2 from the scores in condition 1. I have already mentioned that. And I won't fail to recognize that this data set was obtained from a book by Lenin. Okay. It's a book. I will record that book and I will present the details as soon as I come. I get it. Yeah. Then let's continue. Yeah, that book is by Judith Green and Manuela Oliveira. Judith Green and Manuela Oliveira. It's a section of their book. That book is very easy to use for psychological statistics. So that's where we got this data from, these data sets. So I will encourage you get a more recent version of that book. It will help you. Then the sum of the difference, summation D, is calculated taking into account the plus and minus sign. The sum of the difference. You have to calculate it for those who are not too good in mathematics. It's very simple. I always advise that you calculate all the positive signs and then calculate the sum of the negative signs. Subtract the sum of the positive signs from the negative sign to get the answer. That's one simple way to do it so that you don't make mistakes. Then the sum of squares of the difference, summation D square, is calculated by adding the positive scores, all the scores here. You add everything. Then take us to the next step, the steps we have to follow to calculate t-test. This is step-by-step instruction for calculating t-test related or PET sample t-test, as we've said, we've notified you before. So step 1, calculate the difference. We have done that. We saw it in table 9.3, and then we calculate we sum the difference and also square the difference. We sum the difference here, we got 27. Then you square the difference, and then you sum the squared differences. We have done all this from the table there. Then the squared total of the difference, you get that this squared total of the difference is by multiplying the sum of the difference, 27 by 27, you get 729. Then you find the total number of participants. It's already in our text here. The total number of participants is 10. Then find T using the formula. So this is the formula. t equal to summation d divided by square root of n summation d squared minus summation d all squared divided by n minus 1. So this is very easy. We have got n. N is 10. Summation d is 27. Summation d squared is 10 times summation d squared, which is 151. Then summation d all squared is 27 squared, which we calculated here, 729. Then n is 10 minus 1. That's here, we get it. So when you do the little arithmetic here, the little calculation you can do here, 10 times 151 will give us 1510. Then we've done this, 27 square will give us 729 divided by 9. It will give us 886.78. Then we divide 27. Sorry, this table here is a bit faulty. The 27 should be above the square root. So when we divide 20, we find the square root of 86.78. The square root will give us 9.315. 9.315. And then we divide 27 by the square root of 86.78. So we get 2.89. 2.89. And that is our T. That's what we calculated. So it's quite straightforward. Please take note of this error here. So the square root should have been under the denominator, here where we have 86.78. So now the next thing, step 8, is to calculate the degree of freedom. The degree of freedom has a formula, unlike what we obtained at while calculating Pearson. In Pearson, the degree of freedom is n minus 2. For t-test, paired sample t-test is n minus 1. So it's now 10, n is 10 minus 1. That will give us 9. So the next step is to look up the significance level from the table. I have a table that we shared in class. You can use table C. And table C, if you don't have the table, this is what the table looks like. This is table C. So you need to use the degree of freedom to check table C. It's quite easy to do it. We use level of significance 110.05. That is the default we use in class. So level of significance 110.05. Then you marry it with the degree of freedom 9. And this is what you get. Marry this with 9 here. You get 1.833. That is our T table or critical value. That's our T table or critical value. So that's the simple process of obtaining that particular value. Then you have to take a decision. There is a decision rule, and the decision rule is the same. Even when we did Pearson, it's the same. You just simply check if your calculated T value is greater than your table value. Your calculated T value must be greater than your table value. In our own case here, our table value is 1.833. That's it here. And our calculated T is 2.89. And this is larger than the table value. Therefore, we conclude that there is a significant difference That means the null hypothesis can be rejected. The null hypothesis can be rejected at 0.05. Please take note. Even at 0.091, you will still have to reject the null hypothesis. So that's our conclusion, which means that there is a significant difference in the mean scores. There is a significant difference in the mean scores. If we go back to the means, you will see that 6.4 is way significantly different from 3.7. So, which means that uh, reading a simple textbook, you recall better than when you read a complex textbook. So, there's a significant difference when you recall when you read a simple text than when you read a complex text. So that's the uh, simple explanation. So for you to practice, I have made available a simple assignment for you, to take home assignment. You can see it. The psychologist is investigating whether participants perform better on a memory task after drinking a cup of coffee. In the experiment, 10 participants were asked to take a memory test twice, one before drinking coffee, condition one, and once after drinking coffee, condition two. The participant scores are listed in the next slide. So you use a paired t-test to determine whether there is a statistically significant difference in the participant memory scores before and after drinking coffee. Just follow the process we have shown above to solve this. So we still have similar 10 participants. Then this is the scores, condition one, before drinking coffee, pre-coffee score. And then this is the post-coffee score. Your main goal is to see whether there is a mean difference in memory, recall, remembering, or recall, yes, in this case. So whether there is a significant mean difference. Mhm. So it's important. And then there is something that I omitted to tell you. It's important to note that when calculating this value, you don't, assuming you have a negative score, minus 27, for instance, you ignore it. You can still continue your calculation. What it means, you will end up having a negative T score. And what that simply means is that the the higher score is on the condition two, the higher mean is on the condition two, which means that it's likely the other one may impact better, but that is if it is significant. So take note of this and have a lovely day ahead. Thank you. And remember to subscribe to my channel and like this video so that we can continue to send you such videos. Thank you.